Hey, physical science. We are continuing on, you little spark plugs, into our motion chapter. So just to recap here, what we're now going to be covering in this video is acceleration. We'll kind of compare the two things, but you guys know it as acceleration. We'll call it something called non-constant motion as we go here. Just to review, constant motion is when, like our last part of our chapter, if I'm going 3 meters per second, in the next part, I'm still going 3 meters per second, I'm still going 3 meters per second in the same direction. It's not changing, which is why we call it constant. The opposite of this is called non-constant motion, and it is the exact opposite. So what that really means is we're not covering the same distance. You guys oftentimes know this as speeding up or slowing down, and we'll talk about that. Just to recap here, two words we need to be good at by now. We know that speed is the rate at which an object moves, and that's calculated with the distance it's covering and the time it's doing so. Whereas velocity is what we call that vector quantity where it has direction. So it's the same exact thing, but it has a direction. So examples, speed would be 45 miles an hour I'm moving. A velocity is 45 miles an hour to the east. It's the same exact concept, but it's with a direction added. So getting into acceleration now, a lot of kids just think that when we accelerate, it's just speeding up, but that's not really true at all. What acceleration truly is how an object's velocity changes and the rate at which it does it. So it's really important we understand it's the changing of velocity. And with that in mind here, it's not just speeding up. If I slow down, I'm changing velocity, so that's acceleration. And this one really gets a lot of kids, but when I change directions, technically that's changing my velocity since that's a vector that has direction. So even when I turn left, technically I'm accelerating because I'm changing direction there. So when we go to calculate acceleration, you need to understand it conceptually. It's when we change its velocity. But when we calculate it, we'll use the letter A. And you'll never have seen these before. Maybe you have in class, but this little triangle is delta. And what that means is the change in. So what we're looking at is how does the velocity change and what time period does it do that in. So there's that idea, that change in velocity. So the way that we'll actually write this in class is VF minus VI, and that's going to look really confusing at first, but it's how much does it change, and what VF stands for is the final velocity. So that's how fast it's going at the end of the motion, minus what it started at, which is called the initial velocity, where we started at. So you can see how that directly correlates to what we're talking about with our velocity change. What did I finish at, and what did I start at, and how did it change, and what time period did it take place there? Obviously, if a car goes from 0 to 60 and a minivan goes from 0 to 60, the time they do that in is really, really important when we look at that acceleration. This is going to also kind of throw you for a loop, but the way that we'll express the units of acceleration on top, when we're looking at velocity, that would be meters per second. On the bottom, we'll normally, in the SI system, measure time in seconds. These seconds aren't going to cancel out because they're in different proportions of that fraction. So what the units truly are meters per second. And what that's showing us is how much is the speed changing in meters per second. So I know that's tough to wrap our heads around, but it's how much is the velocity changing per second. Sometimes you'll see this written as meters per second squared because that's how these two values would come together there. So, just like with our normal speed problems, when we're doing problems with calculations, the three steps I've always taught are B, P, S. First, start out with the questions asking and write our blank equations so we know what we're working with. Then P stands for plug it in, plug in what the problem gives us, and finally we solve, calculating and paying attention to our units. Okay, so let's go look at an example here. Make sure you're paying attention to if it's constant motion, like our problems were, or acceleration, where the thing is speeding up or slowing down or changing direction. Doing an example here. A car is at rest at a stoplight. That means in the beginning it's sitting still, its velocity is 0. It pushes on the gas for 5 seconds as the light turns green. When at the end of that, after 5 seconds, the car is traveling 15 meters per second. Find the acceleration. So, we're looking for the acceleration. We know that this problem is speeding up or slowing down, so I'm going to use my acceleration problems. VF minus VI over T is my equation, so final velocity minus my initial velocity divided by time. So when I go look here, at the end of my acceleration, I'm going 15 meters per second. At the beginning, or my initial velocity, I'm at rest, which means it's 0. And we know we got to go figure out the time that took. And if I go plug that in, that's 5 seconds it took for it to speed up like that. If I go solve that now, here's my units, and those seconds don't cancel out because this technically is the top of its fraction, and this is the bottom of its fraction. So we go and solve 15 divided by 5 is 3, and our units are meters per second per second. And what this is saying here is that every second that passes, the car is going 3 meters per second faster than it was. That's how its velocity is changing, and it's positive because it's speeding up. Speaking of which, let's do one more example. Feel free to pause these and slow down and follow along as you need to. A boat was traveling 40 meters per second when the driver slams on the brakes and slows to a stop in 10 seconds. What is the acceleration of the boat? So with that being said, we're looking for acceleration. We're going to start out with our blank equation, and this one throws kids for a loop. You can see how I write here. Kids really struggle with the final velocity. In the beginning, I'm going 40 meters per second, but a lot of kids will say, well, I don't have any more numbers. So what we actually look at here is at the end of my motion, it slows to a stop, which would mean, or rest sometimes it'll say, which means in the end I was going 0 meters per second, minus my initial velocity, which is what I was going at the beginning, and that was 40 meters per second, and I can see the time that takes is 10 seconds. And when you guys go to solve that, everyone thinks they're doing something wrong because it's negative on the top. When you solve that out, it does give you a negative value. And again, there's my units of meters per second, and this actually is correct. And the reason why is because negative acceleration means it's slowing down every second until it reaches 0. So technically, every time you have a problem that's slowing down, you should get a negative acceleration. So keep that in mind with all of your stuff. Pay attention to what the problem's asking. It's going to take some practice. You'll have to struggle through a little bit, but check the answer keys. Do your best. You guys are going to be just fine. Good luck. Email if you have questions.